Complex numbers, we are looking at now the power of I. So how do we know about the powers of I? I cube is what? I square into I square is minus 1. So it will give you minus I to the power 4 is nothing but I square to the power square. I square is what? Minus 1. Minus 1 to the power square is 1. I to the power 5, that is I square to the power square. We know I square is minus 1. Minus 1 square is 1, that is I. It will give you I to the power 6 is what? I square to the power 3. I square is minus 1. Minus 1 to the power 3 is minus 1. And minus 1 cube is minus 1. What about I inverse? I inverse is nothing but I inverse is 1 by I. This is 1 by I. Let us multiply numerator and denominator by I. So this gives you I square, that is minus 1, and this is I. So this will give you minus I. How about I to the power minus 2? This is actually 1 by I square. I square is minus 1. 1 by minus 1 is minus 1. Similarly, I to the power minus 3 is 1 by I cube. This can be written as I square into I, that is minus 1 into I, that is minus I. Multiply the numerator and denominator by I, you get I, and this is I square with minus 1. So a minus 1 into minus 1 is what? 1. I. What about I to the power minus 4? 1 to the power I4. I to the power 4 we have just found out. This is equal to 1. So equal to 1 by 1 is 1. So you have to just learn and understand that I to the power 4k is 1. So I to the power 4k plus 1 is I to the power 4k plus 2 is minus 1, I to the power 4k plus 3 equal to minus I. So what will be I to the power 17? What will be 17? 17 is what? 4 into 4 plus 1. 4 4 is 16 plus 1. Where it fits? Here. So it will give you I. The result will be I. Okay. And if you have minus, then the power is 17, so it will give you minus I. So I to the power 17 minus I to the power 17 will give you minus of 1. I told you this because we are going to use it in the later discussion. So the square roots of a negative real number, what it means? You know that I square is minus 1 by now. What about minus I square? It will give you again I square minus 1. So I square is minus 1. Minus I square is also minus 1. So the square root of minus 1 is what? It is I and minus I. But this symbol under root minus 1, this means I only. What we are getting here is I and minus I. These are all the solutions of, these are the two solutions for x square plus 1 equal to 0, that is x square equal to minus 1. So either you place, in this case, either you place I square or you take minus I square. It will give you minus 1 only. What about this root 3i? Take these separately, root 3 square and I square. Root 3 square will give you 3, I square will give you minus 1. So it will be minus 3. Again take minus root 3i. Take minus of this. So just keep this value and I separate. This will give you root 3 is square is 3 and this minus will become plus. I square is minus 1, so it will give you minus 3. And you see that the roots of minus 1 is I and minus I, but the root of minus 3 is again root 3i and minus root 3i. What we are suggesting here is under root 3 is or can be represented by root 3i. How? Because root 3 minus 3 is nothing but root 3 minus the root 3 and root minus 1. This is root 3 and this is I. So you can write this like this expression like this. So a is a positive real number, and you know by now that under root minus a is root a under root minus 1. This is what I. So under root ai, just to explain this, we already know that under root of a into under root of b is nothing but under root of ab. But this is for positive real numbers. This holds true if a is greater than 0 or say b is less than 0. This holds true also for if a is less than 0 and b is greater than 0. But what about these two numbers if they are less than 0? Let us check it out. I square is what? Under root minus 1 under root minus 1. Take both inside because we are following this now. Under root minus 1 minus 1. We are assuming this to be true for all real numbers, not for everything, But under root minus 1, minus 1 into minus 1 is what? Plus 1. This is under root 1. This is 1. Under root of 1 is 1. So I square has become 1. And we know that I square, we have already discussed that I square is equal to minus 1. So this is a contradiction. I square, if we use this, I square became 1. Actually, I square is minus 1. So this two contradicts. So we deduce that under root a into under root b is not equal to under root ab if a and b are negative real numbers. If this is the case, this is not going to hold. And if we check out for a, b as 0, these are 0, under root ab is 0. Okay. So we can prove certain identity, and you know that x plus y whole square is what? X square plus y square plus 2xy. But the case of complex number is somewhat different. Though these two equations seems to be exactly similar. But let us see. Z1 plus Z2 whole square is what? Take this and take this, because this is square. Now just use the distributive law. Z1 into this one and Z2 into this one. Now multiply inside. Z1 square, Z2 Z1, Z1 Z2, Z2 square. But we know that these two are equal. How? Because we have already seen in multiplication commutation law. These are equal because of commutative law. So Z1 Z2, and this can be written as Z1 Z2. So now this can be added to Z1 Z2. So we can find out and prove also these identities. Z1 minus Z2 whole square is equal to Z1 square, Z2 square minus 2 Z1 Z2. Cube is Z1 plus Z2 whole cube is Z1 cube, Z2 cube, 3 Z1 square Z2 and 3 Z1 Z2 square. If we take a subtraction of cubes, Z1 cube minus Z2 cube minus 3 Z1 square Z2 and plus 3 Z1 Z2 square. If we take Z1 square minus Z2 square, it will be Z1 plus Z2, Z1 minus Z2. And we need to tell that most of the identities which are true for real numbers, they are true for complex number also, but not all. As we have just seen that root a, root b is equal to root ab is not true for the real numbers, these complex numbers. Let us take some example now. A plus bi, we have to place these in the form of a plus bi. So let us multiply minus 5 by 1 by 8, that is minus 5 by 8. How about I into I square, that is minus 1. So minus minus cancels out, 5 by 8. But we have to write it in the form of a plus bi. So this is a plus, because there is no I term, we have to use the 0. Again here, minus I, let us take a different, different entities differently. This is minus I. From here we take I. From here we take I cube. Rest 2 into minus 1 by 8 cube, and it will take minus sign, because minus 1 by 8 minus 1 by 8 minus 1 by 8 will give you minus 1 by 8 into 8 into 8. So we take this term. What about these? This is minus I, this is I, and this is I cube. Let us take minus here and forget about this minus. Let us take minus here. So this is actually minus I to the power 4 into I. Minus I to the power 4 into I. What this is going to give you? This is nothing but minus I square of square. Minus I to the power 4 will always give you plus I, because any minus 1 power, even power, is going to give you positive. So it will give you positive. So let us forget about this. I square is minus 1. This is minus 1. Minus 1 square is 1. So you will get only this I. So you will get only I. 1 by 256 into I. How about this? Let us use the expression we have just learned and combine these two terms, 5 cube and this. These two will come together, this and this. What about this? I square is minus 1. And what about this? 135. So 125, 135 will come together, and these two will come together. How about this? Example 4. Here, something is different. This is under root minus 2. So you have to write this under root minus 2 as under root 2 and I. Under root 2i. Now multiply. This by this, this by this, this by this, this by this. So you'll get these terms. Combine these two because this I square is going to be anyway minus 1. These two, this will be plus minus 6 plus 2, 2 and these two terms. Root 3, 1 plus 2 root 2i. Now the modulus and conjugate of a complex number. Z is equal to a plus ib is our complex number. What about the modulus? Modulus is represented by these two bars. In between we have z. So this is defined like this. Under root a square plus b square. You take this term, square it. You take this term, square it and just take under root. So the conjugate is like this. What about this modulus? What about the conjugate? Conjugate is represented by z bar. So the complex number a minus b, the conjugate is nothing but a minus b. How? Because a plus ib, you just change the sign of the value which comes with I. So a plus ib, you make a minus ib. Let us take a certain example. 3 plus I, you have to take the modulus. So 3 square and what is here? 1 square. What about this? 2 square and minus 5 whole square, and add them and take square root. Now we want to find the conjugate. 3 plus I, take minus of this, 3 minus I. 2 minus 5i, take the positive of this, means the sign. 2 plus 5i. What about this? You have to change the sign of this. So this will be equal to 3i minus 5. And one more, we can deduce by previous discussion that z inverse is 1 by a plus ib. Because what? Z is a plus ib. So z inverse will be 1 by a plus ib. How you can get it? Multiply the numerator and denominator by a minus ib. So you will get this. A minus ib by a square plus b square, which is actually z bar, which is our conjugate, and this is nothing but the square. A square plus b square is what? Square of z square. So square of z square we have written. So we have an expression now. Z into z bar is equal to modulus z square. We'll use it. But before we go and use it, there are other results also. Z1 Z2 modulus is independently Z1 Z2. Z1 Z2 divide, and then we have this is the modulus, so you can do it independently. Z1 modulus, Z2 modulus, Z2 cannot be 0. How about Z1 Z2 whole conjugate? You can take separately and make the conjugate. How about Z1 and Z2? This is the conjugate, so you can take them separately and take the conjugate. Z1 by Z2 of conjugate, you can take them separately, but Z2 cannot be 0. So multiplicative inverse of 2 minus 3i. This is an example. We'll use the just expression we have learned. Z bar is what? Take this plus. So 2 plus 3i. We are just changing the sign. The modulus square is this square plus this square. So 2 square, and minus 3 square, that will be 30. And Z inverse is clearly Z bar by modulus of Z whole square. This is Z bar, and this was our modulus of Z whole square. So you get this expression. The original way was 1 by 2 minus 3i. Multiply numerator and denominator by 2 plus 3i. You get a square minus b square here. This one 2 plus 3i, and this eventually gives you 13. So these two are exactly similar. How about making this as a plus bi? You have to multiply the denominator by the conjugate. So multiply the numerator and denominator by the conjugate of this. 1 plus root 2i, 1 plus root 2i. Because we want a square minus b square formula. You multiply these two, and this is 1 minus root 2i square. This you can easily find out, and the denominator is 1 square minus root 2i whole square. That will give you only 2. 1 plus 2 is 3. So this will be your expression. If you take 3 common, this gets cancelled out. How about I to the power minus 35? This is 1 by I to the power 35. Actually, it is I to the power 34 into I. I to the power 34 can be written as I to the power I square 17. And we have known that I square is minus 1. Minus 1 to the power 17. And you know minus 1 to the power 17 is what? It will give you minus 1. So minus I, this is going to give you, multiply the numerator and denominator by I. You'll get I minus I square, that is I square is minus 1, I square is minus 1, minus 1 is plus. So this will give you 1. So you're left only with I. So this was again very good session, because we have covered the conjugate and modulus that is going to be used very often when you're dealing with the complex numbers. So we'll be taking more discussion. Thank you so much. Take care of yourself.